Okay, I'd like to make a brief about today's agenda as myself. I used to work for vendors, manufacturer vendors, and system integrators, and now I'm working for ThinkMo as a network teacher. You can call me Jason, and my CCIE number begins with 14XX, which is a quite old one. So I've been teaching networking for over 10 years, and I have CCIE, also H3C SE, which is H3C Senior Engineer, and the TCP. TCP is one Tencent Cloud Solution Architect, and other networking professional certificates. And today we have 3 topics. The first one is why we need dynamic routing protocol. And the second one is the concepts of OSPF. And the third one is the basic configuration of OSPF. So for the next 90 minutes, we will be covering the essential dynamic routing protocol concepts and skills, one of the most useful skills for networking professionals to demonstrate your competence in network. And I was wondering how many students here are familiar with network equipment or dynamic routing protocols like RIP, OSPF, or even ISS. So you can type one as a yes, or I'm familiar with, or you can type 2 for you're not. It's totally okay if you haven't or haven't learned something like this before. I just want to get a sense of you guys' background in order to teach more effectively. Okay, so you can type it in the chat box so that I can. Okay. Yeah, okay, so OSPF and BGP, good. And Jahara, I don't know if that's in the right name, Jahara too. Okay, that's good to know. Okay, that's okay. Sounds okay. Sounds good. So dynamic routing protocol can be complex with many concepts and steps to remember. So for your better understanding, please feel free to ask questions when you need clarification or further discussion or further explanation. It's totally okay. You can submit your questions through the chat box by typing 1, and our tutor and I will respond and provide an answer. You can also add our TG group as below and WhatsApp as below to get further information. Okay, so you guys ready? I have to switch it over. Welcome to join. Okay. Okay, let's get our ball rolling. Before we get to know the dynamic routing protocol, the first thing I want to emphasize is static route. Okay, static route is an approach to reach different subnets, and I think you guys already know that. And static route is stable because we configure it manually, so it's stable and it's easy to use. You guys may already know how to configure static route by on Cisco devices or other vendors like IP route, blah, 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 like this. So static route is stable, it's easy to use, but it has some obviously disadvantages like difficult to manage, poor scalability, and no automatic recalculation, and no convergence. So why I mention that is I want you guys to know static route has some disadvantages like this. Let me show this topology to you. So as you can see, here's a topology here. Okay, let me just use screenshot for you to better understand this. Can you see my screenshot and like I'm drawing something? If you can see this, please type 1 in the chat box so that I can know you. Okay, good. Raza said yes. Okay, good. That's good to know. So in this topology, okay, we have 5 branch offices. Like we have a headquarters, we have a state farm in, let's say, in US, okay, United States, and we have 5 branch offices. So in this case, for US, if we want to access the server farm, we need to connect. We need to connect like this. And what we need is static route. We need to set a static route manually so that we can connect the server farm and server farm can connect to the US branch. So basically for one branch, we need to configure 2 static routes. One is for transport this direction and one is back. So let's say we have 5 branch offices. So how many static routes we need? Can you type it in the chat box? 3. Why is 3? Okay, it's okay. 10, 5. Oh, there's a lot of answers. Okay, so basically we need 10 static routes. Why? Let me share you this one. So for static route, we need to configure static route for this direction to access server farm, and for server farm, we need to go back. So that's 2 static routes for just United States. So what if we have to access the Indian or Malaysia or Singapore or China? So basically we need this one, that's 4, and this one is 6, and this one is 8. We'll go back, and this one is 10. So if we want to connect a server farm for these 5 branch offices, we need to configure 10 static routes here. Okay, that's a lot. Not mention or, okay, I get it. Let alone what? Let alone we didn't configure a full mesh network. Okay, let's think about a full mesh network. What is full mesh network is? We just configured the access layer routes from United States to the server farm. So we need to configure 2 static routes. So what if we want to make a connection or make a connective between United States and Indonesia? Let's say we need to configure extra 2 static routes between US and Indonesia. So what if we want to connect between US to Malaysia? We need 2 more, and we need 2 more here, and we need 2 more here. That's just for United States. So what if the Singapore want to access China? So basically we need 2 more. That's a lot, right? That's a lot. So if we want to configure, if we want to build a full mesh network by using static route, that's challenging, that's demanding, right? That's demanding. So what if we have like this? Let's say we have 9 branch offices. How many static routes you need to configure for full mesh? Is there anyone who can answer this question? Okay, I think that's a lot, right? That's a lot. For access the server farm, we need 2. So we have 9 branch offices. So basically we need 18 static routes here for just the server farm and the branch offices. So if we want to build a full mesh network, I think there's hundreds of static routes that we need to configure. That's challenging. Okay, so may I ask what's the benefit of a static route? Okay, let's go back to the static route. Static route is easy to use, is stable. It is stable. Okay, so let's say if we want to configure static route, we can simply use IP route, blah, 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 blah. Like this. And next hop is, let's say, so if we configure the command in Cisco router, so we configure default route. It's easy to use, right? So, and it's stable because if there's no modification, then the static route will be there, like permanently. Okay. But the static route is difficult to manage, poor scalability, and no automatic recalculation and no convergence. So we will prove that points later. Okay, not here, not now. So you will see that if we have a such a big network to maintenance, to build, or to establish, we need to configure a lot of static roles. Well, we have a lot of static roles that we need to configure. That's really demanding. That's really challenging. Okay, so that's the reason why we need to have a mechanism, or we have an approach we call it dynamic routing protocol. So before we go to the dynamic routing protocol, the first thing I want to emphasize is dynamic routing protocol is a language. So you may understand or you may not understand, but please just take a note, okay, on your notebook. Dynamic routing protocol is a language. This is the first thing we need to know, okay? And dynamic routing protocol enables routers automatically to adjust or react to changes in network topology. And nowadays we have several or a bunch of dynamic routing protocols like RIP, like OSPF, like EIGRP, and BGP. You may have or have heard that name before, okay? So unlike static routes, we build our routing table. We create our routing table by some protocols like OSPF, okay? So we have a lot of routing protocols here, but today we are gonna learn OSPF. And you guys will, I think you guys will gain valuable knowledges on how to configure it, how to troubleshoot it in your network, okay? So the first thing is OSPF has some features. The first thing is loop-free, okay? It's loop-free. Why is loop-free? Because it is using an algorithm, we call it Dijkstra, one of the famous algorithm we are using like in a lot of protocols. And we use it to calculate the shortest path tree. And by cost, you just type it in your notebook and we will learn this later. And it has, the next feature is fast convergence, okay, fast convergence. So I want to build a topology to prove that for your better understanding, okay, for your better understanding. So let's take a look at our topology today. So can you see my screen? This is a topology here. Can you see that? You can type 1, so means you can see that. Okay, good, good. Okay, the first thing is, just like I said, OSPF is a loop-free routing protocol. And when it comes to dynamic routing protocol, it's a language. So let's say I want to prove that OSPF is using some kind of language and it will calculate the shortest path tree. So I want to ask you some question. Let's say this is the man in United States, okay, in US, and there's another man. This man want to travel to like how about Singapore, okay, how about Singapore? So the cheapest way is what? Is we buy a plane ticket, right? We buy a plane ticket. So when it comes to plane tickets, basically we have a lot of options that we can choose. Let's say if we want to move from United States to Singapore, so the direct flight, maybe it will cost you like $1,000. Okay, I'm just making some examples, okay, not real world. Okay. So let's say for the direct plane, it will charge you $1,000. Okay, but there's another one is, another way is we stay in Japan and we transport it from Japan to Singapore, and that may cost you like $800. So in this case, which one will you guys choose? You can type 1 for the 1,000 and you can type 2 for the 800. Yeah, I saw 800 on the chat box. Yeah, of course you will choose the 800 RAM because what? Because you know that's cheap. Okay, that's cheap. Because we all like bargains, right? Okay, we will choose a cheaper one. Why we will choose a cheaper one? Because we know what? We know there are some kind of options. We know we have options that we can choose, right? Okay, there's one. But some, yeah, that's, you prove that you are rich, okay? But two hopes we have to cross. Yes, 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 that's correct. That's correct. So I know you guys may reach, but this is just an example. I just want to know that we have options that we can choose, right? Okay, let's say if we don't know, the two, we have options or we have alternative options. There's just one way. So which means what? Which means you don't have choice. You have no choice, right? You have to pay 1,000 USD for transfer you to from United States to Singapore. Okay, but when it comes to options, let's say we have one option or two options or three options, we may choose the cheapest one, right? Because that's cheaper. We can definitely save money. So how can we know that? That's because we can use kind of website like Scanner or whatever. We can use this website to know that we have options. So we can choose, okay? So if you don't have options, you cannot choose. Let's say there's just one option, so you cannot choose, right? It's just like the routers, okay? Just like the routers. Let's say this topology here. This is the PC1 and this is the PC2. Okay, for PC1 and PC2, the connectivity, we have two options. We have two options here. The first one is we can go this path to reach out to the PC2. And we can also choose this one to reach out to the PC2. So I may ask you some questions like, okay, if you were there, which one will you choose? You will go up. For the upper one, you can type 1. For the option below, you can type 2. Okay. Let's wait for a while for you guys to answer. Okay, so Bahas, I don't know how to pronounce the name. Bahas type 1. Can you tell me why you type 1 as your first choice and Raza type 2? So types 2. So can you tell me why you choose the option below? You can type your answer in the chat box so that I can understand why you can't hear the voice. Can you guys hear what I'm saying? If you can, just type 1. Yeah, I think you may need to log out and log in again, since you cannot hear the voice. Okay, because we can reach faster. Because we can reach faster to the destination. Okay. Okay, so how about your opinion? Steven, can you give me your opinion about this? Why you choose the first one? Faster reachability. Okay. And I saw a lot of guys typing 1. So can you guys give me your reason why you choose the first one? Okay. Faster reachability. Because we can reach faster to destination. 2 is the short path. Okay, so good one. So we know that for let's say in this topology, we have two passes here. We have two options here, which is the first one and the second one. So let's say if I were you, I would definitely choose this one. Why? Because it's shorter. Okay, obviously it's shorter. Let's say we have how many routes or how many link we can pass if we use this one. So this is link 1, 2, 3, 4. Okay, for 4 steps, we can reach from PC1 to PC2. Okay, that's just 4. Let's take a look at this one. So if we choose the upper one, the first one is 1, 2, 3, 4, 5. So it will take you 5 steps that you can reach from PC1 to PC2. So which one is shorter? Obviously, the red one is shorter. So we will choose the red one. Okay, and just like the OSPF, OSPF will do the same thing just like we do. Okay. Yeah, second one. Okay, let's talk about some questions. Do you guys still have some confusion about this part? If you don't, yeah, okay, no confusion, good. So how from first computer we will not to know how many hops have to travel? That's a good one. That's a good one. We will figure out later. Okay, we will figure out later. Okay. Perhaps let me answer this question to you. So you mean the first one is the PC doesn't know how many hops we will pass in this travel, right? How many hops? Okay, so for PC doesn't know. Okay, PC doesn't know anything about it. Okay, PC just know we have what? We have a gateway. We have a default gateway. We will through all the traffics or packets to this gateway. Okay, we even don't know what the gateway is. Maybe it's a router, maybe it's a firewall, maybe it's just a PC. Okay, so for PC, it doesn't know anything, just through the traffic, through the packets to the gateway. So PC will send it to this router, and router will decide which one is the better one. Okay, so router knows that this one is better, so it will choose the better one. Okay, so PC doesn't know this one, and we will figure out why router knows this one is better later. Okay, we will do some experiments, we will do some lab to explain this. Okay, good. I think that's kind of answered your question. Okay, good. Let's start our lab, and we will do some experimental here. And for your information, I am using EVGNG. Maybe you've heard that, or maybe you don't. But if you want to understand more about this simulator, you can join our Telegram group or WhatsApp to get the information. Okay. I think the router is get started. Okay, since there's a bunch of devices, I will click it one by one. Okay. Okay, can you see my screen? It's like the terminal, like a terminal. Okay, you can type 1 that you can see my screen. It's just like a terminal, and we will do some lab here. Okay, good. Okay, and I will also put our topology here. So the first thing is we will configure a basic OSPF. Okay, the first thing, if we want to run some dynamic routing protocol, the first thing we need to do is we build a layer 3 connectivity. Okay, and we will check it. Okay, the first thing is we on this PC. This is PC1, and we will configure an IP address for it. So let's say we configure IP address like this and give it a net mask. And for me, I like to use this one as its gateway IP address, 254 as its gateway. So I will configure it. And I will go to the R1, which is this router. And this is the Cisco's router. Okay, the first thing is we have to configure the host name. This is a very good habit. Okay, when you do your lab, when you do your configuration, the first thing you need to do is assign a name on this. Okay, so I will host name it as R1. Can you see me? Okay, so we configure the host name here, and now we will configure IP address, which is interface E/02, and I will give IP address for it. So we've configured the default gateway on this PC as this IP address 102.154. So I will assign this IP address on it. Okay, I think there's you guys already know that, right? Is there anyone who don't know what I'm doing here? You can type 1. You can post your question in the chat box so that I can answer it. Okay, so the next thing is in Cisco's router, all the interface is shut down by default. By default. So you need to no shutdown it. Okay, that's a very good habit as well. And next one is we've configured 2 IP addresses here, and we will do is we check the layer 3 connectivity between the R1 and this PC. We use pin to check it. Okay, see, it's working. Okay, and I will configure the IP address for R1 and R2, R3, and PC2. Okay. I may need to explain why I use this one, this subnet 12 as our lab. It's because, we know that this is R1 and this is R2. For me, I'd like to use 12 as its subnet for the connectivity between R1 and R2. So in this case, for R2 and R3, we will use 23. Okay, it's easy to remember, and that really helps you to make no mistakes. So in R1, we've configured this IP address for this interface E/0/0, and we will go to R2 to configure the IP address. The first thing is just like we've done on R1, we need host name net. And next thing is we assign IP address on it. So in this case, we will use 12.2 for this 12.2 for this IP address interface. That's a good way to, you know, to do the IP addressing for lab. Okay, just for lab. Don't use it in your real network or let's say production network. Okay. And check the layer 3 connectivity every time. Okay. Now we'll go to the R2's next interface, which is E0/1, and I will use 23.2 as its R2, so I will use this one. And I will go to R3 to configure another interface. Host name R3 and E0/1 IP address 23.3. And we will check the layer 3 connectivity. Okay, it's working. And next one is we will do configure IP address on E0/2 because we need to make a layer 3 connectivity between R3 and PC2. In this case, I'd like to use 200. And we go to this PC. Oh, sorry, I need to use this one. Stop. Okay, let me shut on it. Okay, IP address configure and no shut down it. Sometimes you may encounter some issues like this, so you just shut down it and no shut down it, since it's a simulator, not a real products. Okay, so we pin it to check. Okay, it's working. Now what I'm gonna do is we configure OSPF on it. Okay, and we will know what it is. Like I said, OSPF is loop-free. It has some features like fast convergence. Okay, and we will know OSPF have neighbors, adjacency, LSA, and LSDB, something like that. Okay. So before we do the configuration for the OSPF, I want you guys to know that, just like I said, OSPF or Dynamic Routing Protocol is a language. Okay, it's a language. So, is there anyone who knows how to configure OSPF? Okay, so let's configure OSPF. You may need to take a note on this. The first thing is we want to configure OSPF or Dynamic Routing Protocol. You use router OSPF here. Okay, router OSPF here. If you use question mark, you can see this is a process ID. This is a process ID. Some students may have confusion about this. What is the process ID? Okay, so let me tell you, process ID is a local ID. Remember that it's a local ID. What a local ID mean is, so you can use this one like 100 on R1 to enable OSPF process. Okay, but you can also use like 200 on R2 to enable another OSPF process, or you can also enable a lot of OSPF processes on one router. So if you use, in this case, I'd like to use one. Okay, unlike ERGRP, unlike BGP, they're talking about AS number. But this one, OSPF, is just process ID. It's totally local. Okay, totally local. You can name any number you like. Okay, any number you like. So we enable our OSPF process. The next thing we will need to do is we announce our interface in our network. So if we want to run OSPF or we want to announce the interface in our network, so we need to do the network command to match our subnet's IP address. Let me show you. So we use network this command, and if you use question mark, you can know this is network number. So what is this? It's just your let's say your IP address subnet on your router's interface. Let's say should run. If we use should run, we will know that there's a E/0. We have a subnet like this, and for E0/2, we have subnet like this. So if we want to enable OSPF on these two interfaces, we need to use network command like this. Network subnet 12. Remember that this is a subnet, not an IP address, not an IP address. Okay, because I know that a lot of students like to use this one. You just type the IP address exactly under the interface to this command. It's not right. Okay, if you type this command, it will reject your command and ask you to type it, because in this case we need to do a subnet. So we need to type the command like this. Okay. And next thing is, if you use question mark, it will ask you to provide the OSPF wildcard bits. Sounds not easy to understand, right? So I may ask you to use an easy way to remember that, okay? Which is, you don't give it, I don't want to say that word. You don't give it, you know what it is, okay? So you can just type it like this, like your subnet net mask. Okay, but you can also type it in the reverse way, is like this. Okay, this is the correct command, but we can also type it like this, just like our subnets. And Cisco router will correct it automatically. Okay, so you don't need to care about this, but not in your test, not in your exam. Okay, so you have to know what wildcard is. Okay, but in our configuration, you can type it. And there's another one is you have to type the area, and there's a lot of areas here. So for you guys as a beginner of the OSPF, just remember we use area 0. Okay, let's say if your network has like 10 routers or less than 10 routers, area 0 is, I think, is totally enough. And there's a question. Okay, you can also type the IP address like this. Okay, so if we type this command, which means we enable OSPF for this interface. Okay, so what if we want to enable OSPF on this interface, just like I did before? We use network 100, then 0, and we use the wildcard and area 0. So in this one, we've finished the OSPF configuration for R1. for R1 because I just want to enable enable OSPF on these two interfaces, and we will enable 3 interfaces later, but not now. Okay, so we go to R2 to enable another OSPF. Just like this, then we use router OSPF 1, and we use network 12 because we know that for this subnet is subnet 12, and for this subnet is subnet 23. So this is the reason I want to use the subnet like this. It's easy to use, easy to remember. You don't need to check the configuration every time because you know that that is subnet 12, that is subnet 23 by their names. Okay, by their names. Do you remember that? Remember that if you guys have any questions, just post it in your chat box so that I can answer it. And we configure another one, another interface. Okay, so we've finished the OSPF configuration on R2, and let's see what we will do for R3. Okay, Stephen, you have a question? Post it. R1 plus R2 minus 12, and the other side will be no. Rather, I think you may misconfigure about the IP address and subnet. You need to remember that every port, okay, let's say R1 has 3 ports here. Okay, R1 has 3 ports here, and this is a router. Okay, for a router, every port or every IP address for each port should be not in the same subnet. Okay, should be in the same subnet. Let me make an example for you. So if you configure IP address like this, that means your IP address will be the same subnet, and it's not gonna happen. Okay, it's not gonna happen. Let's say we go back to R1. So for this interface, 0/0, we configure the subnet 12 here, okay, as the net mask 24-bit. Okay, and for E0/2, we use a different subnet. Okay, so how about we do a test? We configure some IP address with the same subnet for, let's say, E0/3, and let's see what will happen. Okay. Let's see. It will reject your command and then tell you that IP address overlaps. Okay, overlaps. So you cannot use the IP address with the same subnet. That's overlapping. Okay, that's conflict. 12, and the other side will be. Can we do for the same area? Of course, cannot. If you want to use the IP address like this, let me show you. You can do the IP address like this. For R1 and R2, we use this one. Oh, I got it. I got your point. You use 12 for this one, and another way is, so you mean for R1, this side, E0/0, we use 12, and this one is 21, right? Okay, that's good way. That's good way. Okay, that's just a habit. That's my personal habit. You can use my habit and make it as your own. Okay. Okay, good. Okay, let's continue. So basically, we've finished the basic OSPF configuration here. Let's check it. Okay, so we've finished one interface OSPF configuration, and we need to do another one. Okay, that's all for the basic OSPF configuration. And let's see what will happen. So we need to do some tests. And the most efficient way for testing is we use PC1 to pin PC2 and see what will happen, right? So we go back to PC1 and we pin PC2. So yeah, it's working, right? It's working. So we don't need to configure the stack road. We use instead of we use dynamic routing protocol like OSPF to do the configuration. So the first thing is just we go back to our slides. It's loop free, it's fast convergence, but we will talk about it later. Okay, I will prove that. I will do some lab to prove that. Okay, and we do want to know is we just like I said, OSPF is a language. So for a language, we just like English that I'm using. Okay, we need to do some information exchange. Okay, and we need to know which one is the right one for me to exchange my information. Right? I can share all my information to someone which I don't know or what. So for OSPF, we have 3 tables. And the first thing I want to introduce is neighbor table. Okay, so in this case, let's go back to our topology here. In this case, R1 has how many neighbors? Can you guys tell me that? How many neighbors R1 has currently? Okay, so Baha says we have 2 neighbors. 2 neighbors. Okay, 2 neighbors. Good. 2 neighbors. Yeah, you guys are all wrong. Yes, we have 2 neighbors, but not the OSPF way. Okay, we have 2 neighbors, but for R4, we didn't enable OSPF on it. So in this case, we have only 1 neighbor. So we can use show IP OSPF neighbor here, and you can see there's just 1 neighbor. Okay, 1 neighbor, which is R2. Okay, why? Because I didn't enable OSPF on R4, so we just have 1 neighbor. Okay, so we use, how can we check the neighbor, or how can we check the neighbor table? Is we use show IP OSPF neighbor to check our neighbor table. Okay, so for R2, let's go back to R2. It definitely has 2 neighbors, right? So show IP OSPF neighbors. See, so on R2 we have 2 neighbors. Okay, that's just a joke. And next thing is we have 3 tables, right? The first one is neighbor table. The next one is database table, and we have routing table. So how can we check the routing table? Can anyone in the chat box to give me the command that we can check the routing table? Show IP route. Yeah, show IP route. Right. So we use show IP route to get the routing table. So in OSPF, as you can see, we have 2 routes here. Okay, which is coming from the OSPF database. So you can see for OSPF, how can we know this is OSPF routes or not? EIGRP, like BGP or even stack roads, it's because it has a flag O. Okay, it has a flag O. For O stands for OSPF, right? And another one is its AD is 110. So for this AD, definitely OSPF, because OSPF's AD by default is 110. Okay. Okay, the next thing is we need to know. So we have 3 tables, and we know show IP route can check the routing table. We know show IP OSPF can check the neighbor table. So another one is show IP OSPF, and you can use question mark, and there's what? There's topology info. So you can check the topology table, okay? But it's quite complex. So when it comes to topology table, things get quite complicated, okay? So you just remember that we can use show IP OSPF topology info to check the topology table. And we can use show IP OSPF neighbor to check the neighbor table, and show IP route to check the routing table. Why priority is okay? The priority is 64. That's quite not easy to explain as a OSPF learner beginner. Okay, but if you really want to know, our tutor will explain this to you because it takes time to explain this. Another one is what is 110/20? Okay, /20. Okay, /20 means what? Means the cost. This 20 means the cost, and this one is AD. You guys know what AD is? If you know what AD is, type 1. If you don't, type 2, and I will explain this. Okay. Okay, so the first thing is AD. Let's talk about what AD is. AD is administrative distance. Okay, so you can think of it as a priority or something else. So let's say this is the rules we've learned from OSPF, right? And since we have a bunch of routing protocols like EIGRP, OSPF, ISIS, and RIP, and we also have a way to create route, which is static route. Okay, so let's say if we have a route from multiple routing protocol, which one will we use? Let's say we are running OSPF on these two routers. Okay, so for these 2 routers, we can reach the R3. Okay, so we are running what? We are running OSPF. Okay, and we are running OSPF. So what if we have another routing protocol, like let's say EIGRP? Then which one will we choose? That's a question, right? That's a question. So if we are running multiple routing protocol, or we have some static route we configure manually, which one will we choose? We choose it by AD. AD, if we have a row smaller, we will use this one. Let me show you another one too for your better understanding. So in this case, we have the routes to this destination, to this subnet. Okay, and what we are using is we are using it in OSPF. But what if we configure static route to this subnet? We configure a static route exactly what like the OSPF. So I will use this subnet, I will use this net mask, and I will use the next hop, just like OSPF. So if we configure a command like this, and we can use show IP route to check, and that's different. Let me cut the screen here so that you can understand. Okay, so you can see this totally different, right? So the stack road overlaps the OSPF road. Because what? Because stack road has smaller AD, which is 1 by default, 1. And OSPF has the AD value is 110. So for stack road, the AD by default is 1, and OSPF is 110. So which one is smaller? Of course, stack road is smaller. So stack road will be in the routing table because it has the smaller AD to the same destination. Okay, so if you have 2 routes to the same destination, we will choose one with the smaller AD. Okay, so AD is the way we compare from the different routing protocols or stack routes. Okay, so for EIGRP, we have the AD is 90. For BGP, we have the EBGP is like 5 or whatever. So there's a lot of values or a lot of numbers you need to remember. Okay, so OSPF is 110, EIGRP is 90, and RIP is 120. Okay. And next one is Stephen asked me about what is the 20. That's universal. Yeah. No, that's not universal. Just on Cisco router. Okay, just on Cisco router. Okay, only for Cisco. Let's say if the router is Huawei or H3C or Juniper, the AD is different. Okay, the AD is different. So by AD, when in terms of AD, Cisco has its own numbers, but for Juniper, you need to check what Juniper's AD is. Okay. The next thing is that you ask something about this one, 20. Okay, for 20, which means what? Let's go back to this R. This is R2. This is R2, and let's say this is to the subnet 100. This is to the subnet 200. The first thing is I need to delete the stack route. Okay, we delete the stack route, and then we'll both go back to check our IP road. Okay, back to normal. Okay, back to the OSPF, and let's see what will happen. So for this one, 20 means what? Means we have two hops. Let's say hops or 2 links. So this link costs you like 10, and this one is 10. So the total cost is 20. Just like the airplane, like I said before. Okay, so this one is 10, this one is 10. Okay, and so to this subnet, the cost is 20. Okay, so for OSPF, we go back to the question we're at in the very beginning. Okay, which one will we choose from PC1 to PC2 if we are running OSPF? Let's say for this pass, the cost is, this is 10, this is 10, this is 10, this is 10. So the total cost is 40, right? The total cost is 40. But when it comes to another pass, the cost is like 10, 10, 10. So for this way, the cost is 50. Sorry about the, it's not easy to draw numbers. Okay, so which one we will choose? We definitely choose this one because it has the smaller cost. Okay, so that's why we said OSPF is much smarter than the static roads because it can choose the different roads by its cost. Okay, we will choose better one with a lower cost. Okay, 40. Yeah, correct. Okay, let's go back to our next agenda, which is I will prove that OSPF has the feature which is fast convergence. Okay, fast convergence. So if we want to do the fast convergence, basically we need to do is we create a loop. We create a loop here. Okay, I think you may heard or you may know something like a spanning tree in your switching course, or you know that what spanning tree is. Okay, but now we will create a layer 3 loop here. Okay, layer 3 loop here. So when it comes to loop, if we don't have some approach or some way to stop the loop, the traffic will be like this, right? Will be like this. But for OSPF, we don't need to care about it because it has the algorithm to keep the loop free and with the high availability. Okay, so we configure OSPF on these 5 routers, and let's see what will happen. Okay, let's go back to R4. Okay, let's go back to R4 and R7. So this one is R4. Okay, just like I did before, the first thing is you enable it and you give it a name. Okay, you give it a name R4, and we configure the IP address here. Which is, let's say, 40.4. And next thing is we go back to R1. We go back to R1. And we configure the interface E0/1, which is this link. And no shutdown yet. Remember, no shutdown yet all the time. Okay, and you pin it to check the layer 3 connectivity. Okay, it's working. And we go back to R4 to for another interface. And we go R7. This is R7. So we use post name R7 and interface. Okay, and we go to another interface, which is connected to R3. And we'll go back to R3. This is this one. Okay. So if you do the lab just like I did, you cut the topology here, and you will. It's very convenient for you to do the lab, right? You don't need to check the lab. You don't need to check the interface all the time. Okay, I think that's done. So we go back to R7 to check if we do the correct. Oh, sorry, no shutdown. We pin it again. Okay, good. And then we ping R4. Okay, good. So we go back to R4 to configure the OSPF, and we will figure out the OSPF feature. This is R4. Just like I did before, route OSPF process ID. Okay, I will use 1 in this case. And we network the subnet here. We network the subnet here and here. Okay, so in this case, we'll network 14.0 and area 0. Okay, so we enable OSPF on this specific interface. Okay, and we go back to R1 to configure, because do remember, if you configure OSPF, you need to configure both sides. Okay. Because a lot of students of mine configure OSPF is just, oh, teacher, I've finished the OSPF configuration and I checked that only 1, okay, and there's no OSPF here. And we network. Okay, once we finish this one, you can see the log here, a log here. So which means R4 has a new neighbor on this interface, and the neighbor's router ID is here. Okay, this is our router ID, and we network the interface between R4 and R7. And then we'll go back to R7. Okay, so we've configured the OSPF for this interface, and this interface. Okay, and network. And we go back to R3 because we've finished the configuration on R7, but we didn't do it on R3. Okay, so we go back to R4 to check how many neighbors we have. Okay, show IP OSPF neighbor. And you can see we have 2 neighbors. Okay, we have 2 neighbors. And we go back to R7, it should be 2 neighbors as well, right? Show IP OSPF neighbors. Okay, we have 2 neighbors as well. So in this case, we've finished all the OSPF configuration for this area. Okay, for this area. And let's test it. Just like I said, OSPF is loop-free and it has a feature like fast convergence. Okay, how can we test it? I may ask you some questions like this before I do the test. I wonder if you guys know, in this case, how can we test if it has the feature fast convergence? If you don't know, it's totally okay, because that's what I'm doing here. Ping from first computer. Okay, we pin it, and what we'll do for the next one, for the next step. Okay, we will use this one, -T, so we can ping it continuously. Okay. Okay, let me share you what we will do. Okay, let me share you what we'll do. So in this case, we know that the traffic is what? Is from this one to this one to this one to this one, because this path has lower cost, right? Has lower cost. So if we want to, okay. So if we want to trace something, we can use this command trace. and we will figure out the traffic path. Okay, we will figure out the traffic path. So the traffic path is like this: from this PC to the next hop, which is this IP address, and next one is 12.2, which is this one, and 23.3, and our destination, which is this PC. The traffic path is like this. So what I will do is we will pin it continuously, and then I will shut down some interface on R2, and let's see what will happen. Okay. So the first thing is I will go to this R2 to shut down the interface. Let's say we will shut down interface 0/1 and shut down it. Okay, so we will shut down this interface and let's see what will happen. So once I shut down it, you can see the ping is not working. Okay, ping is timeout, but after 3 or 4 seconds, the ping is working. Okay, ping is working, which means what? Even we shut down this interface like this. Okay, after 3 seconds, the path of this traffic, we switch it from this side because I've already shut down this way, so it cannot happen like this, right? So the traffic path is definitely like this, and we can also use trace to check, and you can check the traffic path is like this, and this one is 14.4 and 47.7 and 33.3 and the destination. Okay, and the destination. So that's why I said OSPF has features like loop-free and fast convergence. Okay, it can converge your network automatically, and you don't need to do anything. Okay, but yeah, if you are dealing some situation like this, it just means that you don't need to deal it immediately. Okay, but you will recover your network eventually. Okay, so I shut down this interface and the traffic path switch over to this link automatically, which is amazing, right? So what if I no shut down this interface? And let's find out what will happen. If we no shut down this interface, we can trace this route. Okay, still the upper one, right? And let's wait for a while. And there's question. That's redundancy. Yeah, that's redundancy. Okay, so after a few seconds, you can see the traffic path back to normal. Okay, you can see the traffic path back to normal. Okay, so I was wondering, anyone has any questions like for this part? You can pose your question. If you don't understand, it's totally okay. That's why we are here. Okay, we want to offer some course for your better understanding about the OSPF. Okay, so looks like you guys don't have a question about this part, right? So if you have a question, you just post 1. If you don't, you can type 2. Okay, good. So next one is we can use some approach or some ways to check the OSPF. Let's say I shut down this interface. Let's say I shut down this interface manually. Okay, manually. So R2 will know that this interface is shut down by the administrator. And what will happen is R2 will send this to the neighbor immediately. So the R1 will update to R4, R4 will update to R7, R7 will update to R3. So the whole topology, routers will know that this interface is shut down. Okay, so we cannot choose this path, and we need to switch over to this one. So that's why OSPF can switch over, because it knows that the whole topology. Okay, it knows that the whole topology. Okay, and next thing I want to talk about is OSPF has some, just like I said, OSPF is a dynamic routing protocol. So for dynamic routing protocol, it's just like a language. For language, we can use some way to exchange our information. But for OSPF, we have some ways to check. Okay, the first thing is if we show IP OSPF neighbor, you can see we have some neighbor ID, which is router ID. If you want to know what it is, you can ask our tutor, because it takes time to explain this. And next one is the dead time. Okay, I want to explain what the dead time is. OSPF is a language. Okay, so the first thing I want to ask is, what if R2 is down? R2's power is unplugged by someone. Okay, so what if this happened in your network? As a neighbor for R1 and R3, okay, the first thing I want you guys to know is R1 will keep sending a packet, okay, a packet to query R2, okay, and R2 will respond this packet, and to prove that he is alive. Okay, so if we want to see this, we can use debug IP OSPF packet to check. Okay, I will turn on this feature. I'll turn on this feature here, and you can see a lot of logs here. So for OSPF, we use we can say a mechanism to keep tracking our neighbors by what? By sending hello packet. We can send hello packet to R2, and R2 will send the hello packet to R1. Remember, the time is 10 seconds. Okay, 10 seconds. So every 10 seconds, R1 will send a hello packet to R2, and vice versa. So if we receive this hello packet, the first thing we will do is we refresh our dead time. Okay, so this one is, let's say, is 33, and we do this command again. See, it's different. And if we do it again, that's different. So once we receive the hello packet, we will refresh this timer, which is dead timer. So you do remember that for OSPF, hello time is 10 seconds. Okay, and for dead time is 40 seconds, which means if I don't receive your hello packet for 40 seconds, I think you are dead. Okay, you are dead to me. So what if I shut down this interface again? What if we shut down this interface again? And let's figure out. Okay. So suppose link goes down between the last computer and before router, what happened? Between R3 and the last computer. Okay, we can do some lab experiment for this question. Okay, but now let's focus on this one. Okay, so I will shut down this interface, and let's go back to R1 to check what happened. So at the first moment I shut down this interface, R1 doesn't know what happened. Okay, and you can see the dead timer is quite close into 0. Oh, okay. I think it will be gone. So once the timer is 0, so the neighbor is gone. Okay, so most people use this way to keep alive, to keep alive with your neighbors. So if we don't receive hello packet from your neighbors, then for 40 seconds, then I think you will be dead. Okay, and let's go back to this question, which is, suppose link goes down between last computer and one before router, what will happen? You mean this one, this link down? You mean this one? Something like this? Okay, so if this link down is down, which means you don't have the root for your whole network, Okay, the first thing I will show you is, let's switch back to normal. Okay. So let's wait for a while. So OSPF neighbor. Okay, and we show IP root. So the destination is here, right? So what if I shut down this interface? If I shut down this interface, this root will be gone. Okay, let's try it. Let's try it. Let's shut down this interface E0/2, right? Okay, let's wait for a while. See, the 200 is gone. No 200 anymore, right? No 200 anymore. The reason is, if I shut down this interface, okay, let's go back to R3 to figure out, if I shut down this interface, which means the OSPF network for this interface will disable. Okay, will disable, which means this command is not working because there's no subnet in 200. Okay, which means this command is not working. Okay, if I no shut down this interface again, this network will back to normal. Okay, so but I think that answered your question, right? Okay, got it. Good. Glad to help. Okay, so that's all for the OSPF configuration. Let's have some review. Okay, let's have some review. The first thing is how we configure OSPF. We need to configure OSPF's process number. And remember that OSPF number is local, okay, totally local. And next thing is the RID, which is router ID. So for OSPF, we don't use the IP address to exchange information. We use one we call it route ID. And which one will be our route ID? The biggest IP address of all your interface. Let's check it. Show IP OSPF neighbor. Let's go back to R2 to check. Show IP OSPF neighbor. So for this one, R2. For this one, R2, it has 2 neighbors. Okay, so for this one is R1. R1's biggest IP address is this. So R1 will use this one as its root ID. Root ID is just a symbol. Okay, it's just a symbol. We will use this one to select DR and BDR, something like that. But I think this is for the advanced OSPF technology, not here. Okay, because that may makes you more confused about the OSPF. So let's go back to this our slide. So for OSPF, we have if we want to configure OSPF, we use configure router OSPF with a process ID. And next one is we have 3 tables. First one is neighbor table. We use show IP OSPF neighbor to check the neighbor table, to check if you have the correct neighbor and the correct numbers of the neighbor. And we also can use show IP OSPF database to check the database table, but it's not easy to understand for now. That's also included by the advanced OSPF. And we can also use show IP OSPF to check the routing table, just like we did before. Okay, so do remember that OSPF has its AD, which is 110. Okay, for OSPF 110. And I've made a table compared the difference between the stagger routing or dynamic routing. So for stagger routes, we configure the destination manually, and if there's something change, you will need to do it manually again. So it's secure. It has better security because no one can change your routing table, but yourself. Okay, but in terms of dynamic routing, we have if we have multiple routers, we have a lot of roads to destination, so we need to do the dynamic routing. And dynamic routing is more suitable for the biggest, for the bigger network. Let's say if you have 10 routers or even more. Okay. Some questions. Okay. And remember, OSPF is a dynamic routing protocol with loop-free and fast convergence. Okay, and use OSPF, use hello and dead to keep alive. And how to configure OSPF? You can check this command, and you can also get the slides after class by joining our group, a Telegram group, or at our WhatsApp ID, as we showed before here. And tutor will also post this TG group and WhatsApp in our chat box. Okay, so that's all for today. And I was wondering if you guys have any questions so that we can answer it for your better understanding about OSPF. Yeah, thanks. Glad that you've learned something useful to you. Okay, so looks like you guys don't have questions, so let's call it a day, and I'll still be here, and if you guys have some questions, you can post it here. Okay, and I'll stop sharing.